So in the beginning, I'll talk very briefly about Nanotechnology Research Center. We actually began in 2011 as a nanotechnology chair in water desalination. And in 2016, we upgraded the chair into Nanotechnology Research Center. And today, I'm not going to talk about the chair. We did a lot of work in the chair. I was in charge of the chair from 2014 to 2016. I'm going to talk about the center now. And the center is a research center in Sultan Qaboos University. Our work is on knowledge sharing and, of course, capacity building. And that's where we don't produce equipment or technologies. What we do is we work on capacity building mainly and dissemination of knowledge. And you can see that we have done very good work on this regard. We produced more than 45 publications, worldwide high-impact journals in the past 3 years from 2017. We actually have in 2021 now, we have 7, and we have many ongoing as well. We got 2 patents. We are working on 2 applications now, and we have quite a few in the pipeline as well. Hopefully, we can get them in the next, in this year, in 2021. And we currently have 2 master students and 3 PhD students. Now, before I go into nanotechnology applications, let me talk about water resources. I believe this is always the first thing that comes in mind when we talk about water, that we have a lot of water in the world, but only 2.5% of that water is fresh water. But in reality, only 0.3% of that 2.5 is accessible to all of us. So in daily life, we only have less than 0.001% of the whole water in the world. However, this is not the real story. The real story is we have always lived with that amount of water in the world, how much we have. We can live with that. But we have other sources or we have wastes. It depends on how we look at them. Now, in Oman, our main source of water is groundwater. That's what we use, that's what we utilize. About 85% of the water used in Oman is groundwater. And that water, maybe approximately 88% goes into agriculture. However, we also have a lot of wastewater. And this wastewater, it's either a resource or it's a waste. And whether we talk about it as a resource, we reuse it or recycle it, it will require some kind of treatment, or we can talk about it as waste, and still we will have to treat it because we cannot send it to the environment. It's a huge risk for the environment and the ecosystem. And well, there are many, many different wastewater types. What we always know is domestic or municipal wastewater. This is something that we know a lot about. However, wastewater is not only domestic or municipal water. We also have a lot of other sources of wastewater, and these are very difficult to work with. This is a figure on the applications or the research in nanotechnology for wastewater. You will see that 60% of the applications and research of nanotechnology goes in industrial wastewater. And industrial is very huge market. We talk about the manufacturing wastewater, which is completely different than agricultural wastewater, pharmaceutical and medical wastewater, and other sources of wastewater like textiles or poultry. And with these, we must know that the desalination, the current technologies in desalination and wastewater treatment, these began 30, 40, 50 years ago. And they are built specifically for seawater desalination and domestic wastewater treatment. And that's where they are very efficient. However, when we talk about the new emerging types of water and the current technology is not enough, it's not efficient. And this is where nanotechnology plays a major role, because nanotechnology is capable of treating these new types of water for the next generation, whether for the current, for the reuse, or of course for disposal at the end. Now, this is because water has different contents. nanotechnology, the current technologies, they can treat the top part of those, and nanotechnology is also capable of it. However, we have a problem with emerging contaminants. We didn't have this before because we didn't live in a high standard as we are living now, and we didn't have the technologies to detect those kind of harmful content. And this is why we have, for example, microplastics. Microplastics are a huge problem. They are everywhere. Most of the time, they are not detected because we don't have the technology to detect them. Then we also have the pharmaceuticals, other drugs, and other contents that we don't know, and they are there. And this is a recent study, it's in 2020, where they found that domestic wastewater is only capable of treating 84% of microplastics. Also looking at other emerging contaminants, we find that caffeine and other drugs like salicylic acid, which is used for acne, they are present in river water, and they are also present in drinking water treatment facility. So they are in both. Other drugs, they were removed in the drinking water facility. And this is also a very recent study where it clearly shows that the current technology is not capable of 100% removal of this. And this is where nanotechnology comes. Nanotechnology has a huge potential for this because it has all the necessary areas to work in. It's used in many applications. However, for water treatment, it's quite recent, actually. We have it has been recently used for water treatment and environmental. But nanotechnology is not new. It's not something that came from here. It's actually from nature. Nature is utilizing nanotechnology. All of these are present there because they utilize nanotechnology. And one very big example of this is the lotus leaf and the petal rose. We see them as smooth. However, in reality, they have a nanostructure. And the shape of this nanostructure, it changes what happens to the surface. And in here, it changes on what happens to a water droplet. So one, it has that at the top. It's very uniform, so we have a very uniform distribution of force, and that's why you can see as an application, we don't have an explosion of the balloon. However, for the other part, you can see because of this nanostructure, even though the structure is hydrophobic, it doesn't really like water, but it still sticks to it. That is because of nanotechnology and the application utilization of nanotechnology in the nanoscale. So what is nanotechnology? It's any kind of manipulation of matter, the control, understanding, and the manipulation of nanomaterials in the nanoscale, less than 100 nanometers. So in reality, it's not really a nanotechnology. It's an enabler. Whatever technology we have now, nanotechnology will enable it, will be a pivot so that we can advance it even further. Think of any technology present now, whether in desalination, water treatment, or any kind, nanotechnology has the potential of making it better, while now or in the future. And we can look at gold. This is gold. We know gold, it's a jewelry. It also has other applications. When we look at gold in the nanoscale, it's actually different. It has a different color. It has different properties, its melting point, and it's actually magnetic. Gold at 3 nanometers is magnetic, and it's a very good catalyst as well. So we have many properties that we can make with nanotechnology. But it's not only this. One of the most important facts of nanotechnology is the surface area. The development in the electronics, in our mobile phones and all of that is because of this very high increase in surface area. It's the same paper that we have. It looks smooth, but its surface area is very high, and we can utilize it for many things. This is a human hair. It's one strand. It's about 60 to 70 micrometers. It's a black hair. This is where we work at. This is the nanoscale that we are working in. Each one of those is less than 10 nanometers in diameter. And this is what enables all of these kind of applications, this nanoscale. So applications, there are many applications for nanotechnology. We can use it for remediation. we can use it for treatment, we can use it for desalination, but also we can use it as detectors. And it's one of these applications where we can use it as a sensor, because the current technologies are either very expensive or very complex. But with nanotechnology, we can hear an example of gold nanoparticles. We can use them as detectors and sensors, and this will make the system much more simpler, less time consuming, and more efficient, and of course, simple to use, and definitely cheaper in the long run. And as I told you, the applications of nanotechnology is very recent. Nanotechnology has been used in more than 50 years, but in water treatment is quite recent. And the good thing is in Oman, we began just like what they began. So the advancement that we have in Oman is very similar to the advancement in the world with respect to water treatment. With other things, yes, of course, they are before us because they invested more, but for water treatment, we are basically in the same area, which is very good for us in the future. We will advance just like them. We will work as hard as them or even more. So these are some of the applications that we have done in our center, and we began this as a chair that was funded by the Research Council. This one is basically applying what is nature is applying. We are looking at, this is actually cotton. You know, cotton is hydrophilic. It likes water. Whenever you pour water, it will soak. What we have done is we changed the surface. We added nano rods and nanoparticles in there, and we made it hydrophobic. This is extremely important because this is what we call self-cleaning material. This cotton will not get dirty. It will self-clean whatever you have, it will sweep. But it also have another application. Because it's hydrophobic, it doesn't like water. We can use it as absorbers, oil absorbers or oil sakers. If you put oily water in there, the oil will be absorbed, the water will stay, and then we can use this cotton, we will take it out, and we will recycle, and we will regenerate this oil, and we make use of it. And we have a patent on this. SQU has a patent on this. We also work on membranes. We do a lot of work on membranes because there is a huge potential. Now, membranes are just like this. And there are different applications for them. They are used heavily in water treatment and desalination. If you have a water filter at home, then you are using at least one membrane unit. Probably you are using 2 or 3. So in our daily life, we are using membranes. These are extremely efficient, very good, but nanotechnology enables it to be much more better in all of these areas. And that is what we have done in the center. That's what we have done. We added different nanomaterials to enable us to make this membrane specifically work in a certain water sector for water treatment, depending on what is the use. We are not taking the commercial membrane that has to be done in a specific way. We are shaping the membrane so that we decide on what is the use and what is the efficiency and, of course, the production. And we have an application with carbon nanotubes. Dr. Ashraf is with us on the patent as well. And we are applying all of these nanomaterials in there for specific application. This is one of those. This is done specifically for produced water treatment. We are adding, that's a strand. It's about 1.2 micrometers in diameter for the filter. And we are adding nanomaterials in there for the filter. And you can see the commercial polyether sulfone membrane has a rejection of about 88%, while the one that we have produced has a rejection of almost 98%. So it's very close to perfect treatment of oily water. But usually, without the nanotechnology, with these, if you increase the rejection, the purity of the water that you produce, the problem is going to be the efficiency, how much you are going to produce. But what we found out is, of course, with this, we are actually producing more. So with this technology, we are producing more and we are producing much better higher quality water. Another application is disinfection. And what we have basically is these membranes, reverse osmosis, desalination plants in Oman and all over the world depends on reverse osmosis desalination. 80% of the problems that are faced in desalination plants is biofouling, bacteria that grows at the surface. We know that the membrane is capable of removal. However, the bacteria grow at the surface, and from time to time we either have to stop the system, and sometimes we will have to replace these membranes, and they are expensive. What we have done is we have added again nanostructures, nanomaterial in a specific way, and what we found out is actually these nanomaterials are capable of not removing but killing the bacteria. That is, without nanomaterials, you can see the red, the green. Bacteria is alive, it grows on the surface. With our membranes, the bacteria is dead. Red means dead. So it's not that only we are capable of removing the bacteria, actually the membrane is killing the bacteria. And another one is photocatalysis. It's expensive to treat anything. We are utilizing sunlight. We are using sunlight which is available everywhere to convert any kind of waste water into benign carbon dioxide and water. And this is enabled by nanotechnology. Buthayna is going later to talk about combining this technology with membrane technology in a one system use for the treatment of wastewater. Here is an application where we got about more than 60% degradation of wastewater only in 120 minutes. I would like to, of course, ask our partners, because without them we will not be able to do any of this. Ministry of Higher Education, Research, before it was the Research Council, now it's Ministry of Higher Education, Research and Innovation, Ministry of Agriculture and Fisheries Wealth and Water Resources, Omantel, of course, they are a big contributors in all of this, OQ and PDO. Thank you very much.